and gentlemen, thank you so much for coming to the Twomey Lecture Series. And so we thought we would do a taste-off of the various kinds of drinking water available to you in East Hampton. So we had 3 different drinking water samples. One of them is from our public water supplier, the Suffolk County Water Authority. One is from a private well in Springs. And one is water that you would buy at the grocery store, in this case, Poland Spring. So clearly A was the favorite, B was the least favorite, and C was the runner-up. So this is Suffolk County Water Authority, our public drinking water. Poland Spring, why pay money for Poland Spring, and a private well located in Springs, East Hampton. So this is very interesting. There's definite preferences here, and you shouldn't be buying Poland Spring, I don't think. Anyway, thank you, Dennis.
We should add that A is actually the water from the library here.
Yes.
So if you want to bring your jugs.
Another great service of the library. So it's my great pleasure to introduce you to Sarah Malin, who has a long and distinguished career in studying and working to protect groundwater. She's a water specialist. She's held various positions here on Long Island and elsewhere, working for not-for-profits. She was the director of watershed studies for the Suffolk County Water Authority, whose water you just liked so much, which is the largest groundwater supplying drinking water supplier in New York State. Today, Sarah, she is an environmental lawyer, a highly overeducated woman, many, many degrees, too many for me to even go into here. But today she's the director. Now she works at New York Institute of Technology in Old Westbury, and she's the director of the Center for Water Resources Management and a professor at New York Institute of Technology. Sarah Malin.
So thank you, Sarah, for that wonderful introduction, and thank you to the Friends of Georgia Capon Foundation, and thank you to the library for inviting me here this afternoon. So I'm going to jump right in and get started with talking about water, and really set the foundation so that we have a common understanding of the issues that I'm going to be talking about today. So first of all, let me just say that water stored in aquifers is called groundwater. And all drinking water on Long Island is groundwater. All groundwater here on the island is basically stored rainwater. And all of the drinking water that is used here on the South Fork comes from the aquifer system beneath the South Fork itself. We don't get any water coming in here from part of the aquifer to the west. Once the water is pumped out of our underground aquifers, it is often stored by the water supplier in large towers, and then it is disinfected and it goes out to the customers. So this is a typical makeup of a public water supplier. The water is pumped out of the ground at the pump station. A lot of it will go into storage at this storage tank that is elevated several stories above the land surface. And the tank serves 2 purposes. One, it has backup water when it's needed. And secondly, the pressure created from this elevated water storage creates the pressure that pushes the water through the water main and brings it to the customers. And so this issue of having high water elevated above the landscape is a very important one, and we'll be coming back to this concept. So what are aquifers? Simply put, aquifers are geologic formations that do 3 things. Store water, meaning it holds the water. Transmits water so that the water can move through the aquifer. And 3, yields the water. You can pump it back out in usable quantities. A geological formation that does all 3 is an aquifer. If it doesn't do these 3 things, it's not an aquifer. Okay? So here on the island we have 3 main aquifer formations. The top one is the glacial. It's very young, it's only about 10,000 years old, and it's the one right beneath the land surface. Below, directly below the glacial, is the main aquifer. It's called the Magathy, and just like the upper glacial, it's primarily sand and gravel. And most of the water that we use around Long Island comes from the Magathy. And then below the Magathy is a thick bed of clay called the Raritan. It's about 200 feet thick. And then below it is our last formation, the Lloyd, which is the oldest formation. It was created over 70 million years ago. And our deepest and purest water is down in the Lloyd. It sits on bedrock that doesn't contain any water at all. So you can see that on the left of the diagram, the aquifer extends out to Long Island Sound. And on the right, the aquifer system extends out beneath the Atlantic Ocean. And on the sound side, on the ocean side, the aquifer is very deep, as much as 2,000 feet deep down there. So, well, where is all the water? If the aquifers are sand, where is the water? And the water is stored in between the microscopic spaces between one sand grain and the other. And you can go anywhere on Long Island, and if you dig down deep enough, you'll eventually hit the water table, which is the top of the groundwater system. And once you dig beyond the water table, the hole will begin to fill up with water, as all the water in those little tiny spaces between the sand starts to seep out and fill the hole up. So this is where our water comes from. The wells that we drill into the aquifer and pump the water out of the sand. So a few basic facts you may be interested to know is that we here on Long Island use the most water per person, which is about 130 to 140 gallons per person per day. We use the most water of any groundwater using community between here and North Carolina. So we're very extravagant with our water use. Last year, the Suffolk Water Authority pumped about 76 billion gallons out of the aquifer, and this was just the pumping from a water supplier. It doesn't include all the other water that we pump. The water costs around $400 a year for an average water customer. That's over 181,000 gallons of use per year, and we pay about $1.50 for 1,000 gallons. And so knowing how much water you use is actually important, and I imagine that there are very few people here this evening that know how much water you use per water bill if you are on a public system. So that tells you a lot about how we value water. It's so insignificant in our daily lives that we don't pay attention to figure out, well, how much was that $50 we just paid for 3 months worth of water? But water use is actually quite important, and it has a lot of consequences attached. So for example, you may be surprised to know that the Suffolk Water Authority is the single largest electric user in Suffolk County, because every time you use water, it relies on electricity to get it out, treat it, pump it various places, so it creates a large energy demand as well. Also, using a lot of groundwater spreads pollution throughout the aquifer, increases saltwater intrusion, can affect the stream flow in nearby streams. And if you use a geothermal system, these systems are being promoted as very energy efficient, but they have an issue. They have a consequence for the groundwater, because now you're taking groundwater and putting it through a technology that you're eventually going to use that water for drinking water at some point in the future. So let me just talk about the aquifer system itself. If we connected every one of the highest points on the water table across the length of Long Island, we would end up drawing a red line like the one you're seeing here that is something called the groundwater divide. And this divides the aquifer system into watersheds. And the watershed to the north drains groundwater into Long Island Sound. And the watershed to the south drains groundwater into the Atlantic Ocean. And you can see that if we look here on the east end, this groundwater divide system separates, and we have a groundwater divide for the North Fork and the South Fork as well. Not all groundwater travels everywhere. It basically travels toward a shoreline, one to the north or one to the south. And we can see the groundwater divide here, and the closer that rain falls to the groundwater divide, then the more directly, vertically, that water travels and ends up adding water, what we call recharge, to all three of the aquifer layers, the glacial, the magathy, and the lloyd. And the further away that recharge occurs, or further away from the groundwater divide and closer to the shoreline, less of the aquifers get replenished. And that water stays into the very shallow parts of the system and doesn't feed the whole system. So it's important to understand this relationship of recharge, location, and where that water ends up if you want to protect the groundwater and the surface waters that this water drains into. So this brings us back to, again, how we use our water. So these are three graphs of water use from January to December for 3 different years. And one of the years was very hot and dry, and one of the years was very cool and wet, and one was slightly in between. And so you can see that in the winter months and in the late fall, the water use is very consistent because that's water that we're using as indoor water use. But as you get into the summer months, you see this huge peak, this rise, this increase in water demand and water use, and the hotter and drier the summer, the larger the increase is. So between winter use and summer use, we can increase water use by as much as 400%. So summer is a time when we really use a lot of water out of our groundwater system. Why does that matter? Well, it matters for a couple of reasons. One is that it promotes depletion of the water when we're using a lot during the summer. It encourages saltwater intrusion for areas closer to the coastline. And in the summer, we get very little to zero recharge back to the aquifers. The reason that's so is what this graph is showing you. The blue line is month-to-month water from rainfall. And you can see that it's very consistent. Between 3 and 4 inches a month is what we generally get as an average. The yellow line, the gold line, is evaporation. So evaporation is virtually zero in the winter, and then it goes very, very high in the summer. It goes all the way up to being equal to rainfall in some cases. And the red line is recharge, how much water gets back into the aquifers. And again, you can see as the evaporation goes up, the recharge goes down, and it goes down to virtually zero in the summer. So 2 things are happening in the summer. We have very heavy demand on the aquifers, and we have virtually no water replenishing the aquifer at the same time. So this puts a tremendous stress on the groundwater system to meet our needs, but we don't really replace that water that we're drawing out until later in the year. This is where we're pumping all the water from. These are public water supply well locations, and you can see pretty much the entire landscape has water wells pumping water out of the aquifers. And these are just public water supply wells. We have 45,000 private wells. We have hundreds and hundreds of irrigation wells. We have hundreds and hundreds of industrial wells. We have thousands, several thousand geothermal systems installed on Long Island. And many golf courses, and they all irrigate, and many schools, and they all irrigate. So the amount of water that we take out of the aquifer is substantial each year. So this brings us back to the system as a whole. As we're trying to get water into the system through precipitation, water is always leaving the aquifer system through runoff, through drainage into streams, drainage into ponds, and discharge into coastal waters. So we've got this balancing process going on between water coming in and water constantly going out, plus the water going out through pumpage. And so the bottom line is we want the aquifer to be in a healthy condition. The way to keep the aquifer healthy is to have as much water coming in as the amount of water that's going out. We do that here in Suffolk County, even though we use a lot. We've got a lot of water to work with in Suffolk. In Nassau, the picture is very different. And actually, we're taking more water out of the system. We're losing more water from the aquifers than is coming in. And so the aquifer management is especially critical for areas like Nassau and western Suffolk. So this is what's going on at the aquifer level for every well tapping into the groundwater. These are small wells for individual homes, and for every well that's pumping, it creates a physical change in the aquifer itself. And we start to de-water the aquifer right around that pumping well. And so you can see it creates these little depressions in the surface of the water table. We call these depressions cones of depression. And so these are small little impacts for small wells, but these wells are only pumping about 10 gallons a minute. A public water supply well is pumping 14, 15, almost 2,000 gallons per minute. And so they create very large drawdown impacts. So that leads us to what is the consequence of this heavy use of water out of the aquifer. And for parts of Nassau County, for example, we see this diagram up on the upper right, where we have generalized saltwater intrusion into the aquifer system beneath the land surface. And this is the kind of saltwater intrusion that is creating problems in Nassau County. But a different system consequence occurs out here on the forks, and that's the bottom diagram on the right, where not only do you have generalized saltwater intrusion, but in the deep part of the aquifer, it's already salty. All of the aquifer deep in the system is already full of salt water. And so all you have out here to work with is a bubble of fresh water or a lens of fresh water floating on top of deeper salt water in the aquifer. So where you put wells and how much water you pump from those wells really matters out here. And you can get a consequence of careless pumping where you draw salt water into the well from below rather from the ocean next to the shoreline. And we have problems of upcoming here in the forks that we don't have in the rest of Long Island. So an upcome is kind of the reverse of a cone of depression. And so pumping water here takes a lot of attention and care. So now I'm going to talk a little bit about the details of a study that was done out here on the South Fork to give you a little bit more information about what's special about the South Fork. So this was a study done in the late 90s by the USGS, and it had several interesting findings. A couple I've already mentioned, which is the South Fork and the North Fork aquifer systems are separate groundwater systems. They're separated from the main part of our aquifers. And the freshwater floats on top of deeper salt water. If you go deeper into the Magathie, you run out of fresh water and go into the saltwater part of the aquifer system. And the maximum depth of fresh water in the aquifers only goes down to about 600 feet. And below that, all the water is salty. So this was the study area. It ran from Sag Harbor Cove on the north down to Mecox Bay on the south. And so everything I'm going to talk about is related to this study area right here. And your part of East Hampton is just to the east. So I'm showing here the dashed line, which is the groundwater divide. It divides the South Fork into a northern watershed and a southern watershed. And we have a mound of high groundwater right in the middle of the groundwater divide. And as I said, elevation matters. So in the way that I was talking about the water tower that helps create pressure to push water to the water main distribution system, this high elevation of groundwater does the same thing for water in the aquifers. It creates a pressure that pushes water through the aquifers. And that's why the water is slowly moving toward the shoreline, either to the north or to the south. And so about 30% of this water on the north side of the divide drains into the Peconic estuary, and the remaining 70% of the groundwater in the southern watershed drains into the Atlantic Ocean. So this is a diagram of what the aquifer looks like beneath the South Fork. You can see that this dashed blue line is an indication of where the water table is. And you can see that there are two areas that are unusual for the South Fork that we don't have in the main part of the aquifer system. There are two clay layers that we have in the shallow part of the aquifer system here on the South Fork that is unusual. You don't have this in the rest of the island. And so it creates a bit of a barrier to get water in the deeper parts of the aquifer system. And then you've got the aquifer above this main big clay layer. That is the upper glacial. That's the shallowest of the three aquifers. Then you see these red dashed lines on either side of the diagram. That's the division between the shallow glacial aquifer and the deeper Magathy aquifer. And part of the Magathy is fresh water, that clear area, and the shaded area is Magathy aquifer that is saltwater. So here you're seeing that freshwater bubble, or that freshwater lens, that is your drinking water supply on the South Fork. And all of the water wells are tapping into either the glacial aquifer, which is the most shallow, or deeper into the Magathy aquifer that is your deeper freshwater supply. And eventually the water is either going to travel to the Peconic Bay to the north or to the Atlantic Ocean to the south. And this diagram is showing the clay layers as the shaded areas near the surface. And this is a diagram that was created by a modeling exercise that tracked a particle of water from the land surface down into the aquifer, and then how it would flow through the aquifer system, depending on where at the land surface it entered the aquifer. So you can see that half of the water flows to the north. Some of it goes deep into the system, a lot of it does not. And the rest of the water, the 70% on the south side of the groundwater divide, flows out into the Atlantic Ocean. But what's really special about this diagram is that you can see, I think most of you can see, that there's not so much water deep into the aquifer, and there's a lot of activity in the shallow part of the aquifer system. Part of this shallow groundwater drains into Mecox Bay and into Swan River before that. And so when you're concerned about coastal water quality, this explains why what goes on very close to these surface water bodies is so important, because the travel time from the land surface out to these surface waters is very short. 2 years, 5 years, maybe 10 years or more. But the closer you are to the coastline, the more quickly the water in the groundwater flows out and joins the surface water system. So if you keep that groundwater very clean, it doesn't affect coastal water quality in a negative way. If it is building up with nitrates, for example, then it's going to quickly discharge that nitrogen to the ponds, to the rivers, to the estuaries, and affect that surface water quality. So here is the same diagram, but now the age of the groundwater is being identified. So again, the water very close to the land surface is the youngest water, and as you get deeper and deeper into the freshwater area, it is older, and what this is showing you is how long it actually takes the water to get deeper and deeper into the aquifer. So once again, the young groundwater, if it gets very quickly released to the coastline, and if it's contaminated, then it's going to impact water quality in the estuaries. So let me move on from talking about how the system works to talk about water quality. And water use, pollution, and surface water quality all get related to one another. So we know that when we pump water out of the aquifers, it influences how water flows through the aquifer system. And if we put contamination into the aquifer from a source of pollution, that will get down into the groundwater and slowly move away from the source to some discharge point, whether it's a stream or a pond or an estuary. It flows as a ribbon or a plume of contaminated groundwater slowly over time. So what is possibly in the groundwater that is flowing slowly away from various sources? All over Long Island, we have water quality issues. Not every place has all of the problems, but every place pretty much has at least one or two water quality issues. They might not be terrible, but they're there. So these are all the different types of pollution that we know exist somewhere on Long Island. Our number one water quality problem in both Nassau and Suffolk is volatile organic compounds, VOCs. These are industrial chemicals we use in our household, we use in industry. They've gotten into the environment, into the groundwater, and they're creating really serious water quality problems for us. Nitrogen, nitrates, you're all very familiar with. Spills, gasoline spills, industrial spills. We have 2,000 gasoline spills on average every year on Long Island. Many of them now are not terrible. They have been terrible in the past, but this is an ongoing problem. We have the largest concentration of Superfund sites in the state of New York on Long Island. We have 258, more in Nassau, less in Suffolk. These are places where we know the environment is contaminated, the ground is contaminated, the groundwater below is contaminated. And this is a huge challenge and a problem for us. We have pesticides, more in Suffolk, less in Nassau. 80 have been detected, but it's just a handful of pesticides that are the most common problem here. We have perchlorate, which is a fairly new pollutant for us to deal with. It comes from fertilizer, it comes from jet fuels, and this is creating problems for us in public water wells. And then there are some unregulated compounds. We don't regularly have to look for them. They don't have a standard. We don't know all of the health issues associated, but we are finding them here in the groundwater. One is the PFOA, the PFOS. This is a chemical that is related to things like Teflon or stain-resistant materials. It's used in industry, it's used in food industry, and it's showing up here on Long Island. It was used in the foam that we use to fight fires with. And so that's why it's showing up in some of the fire training facilities. And we have chemicals that are from the pharmaceuticals we use, the drugs we use, and the personal care products that we use. The one that's really getting a lot of attention now is 1,4-dioxane. There's no standard for it. We know that there's some health concerns associated with it, but we don't know what a safe level is. So the two in red, the two chemicals in red, nitrates and chlorides, those are the chemicals that are showing up in the groundwater here in the South Fork. The nitrates, you know, the source of that primarily fertilizer, sewage waste, and the chlorides is probably associated with the saltwater intrusion that you're dealing with here on the South Fork. And this is what a groundwater plume looks like. Whether it's a Superfund site like the Brookhaven National Lab, which has multiple contaminated plumes coming off the site. You can see that they are these elongated ribbons, plumes of groundwater. Some can be very large, a mile or two long, hundreds of feet wide, hundreds of feet deep. So that's a Superfund site. Over on the upper right is a gasoline spill. Gasoline is lighter than water, so it can create a contamination plume, but it stays fairly close to the water table. It doesn't sink deep into the aquifer. And the bottom right is a plume coming out of a septic tank. So for each septic tank, it generates a wastewater plume into the groundwater. If there's only one house in an area, the impact is minor. If there are many houses in an area and they're all releasing septic tank waste, the collective impact can be quite noticeable. Depending on what the pollutant is, we have different technologies to deal with it. We treat drinking water to kill bacteria with chlorine. We take VOCs out with technologies like carbon filtration units up on the upper right, air stripping towers on the lower right. We can take pesticides out with carbon. We can also use reverse osmosis. Nitrates use ion exchange, and we're experimenting with new technology to remove dioxane, 1,4-dioxane. So for each pollutant that we have to deal with, it may take a different technology. All of this uses energy. All of it costs money to maintain and install. So this brings us to our final question. Who is protecting our groundwater? And the message is that there are many agencies involved in one aspect of groundwater or another, but comprehensively, collectively, we have no centralized agency that is responsible for all of our groundwater issues on Long Island. And so this means that key issues that should be attended to aren't being attended to. So we're no different than any other community all around the United States, all around New York, which has come up on the problem of who is going to manage our water resource. We have groundwater, but most of the rest of New York State uses surface water. And much of the rest of the nation uses surface water as well. And the good news is that all of these other communities have come upon an answer, and most of them have come upon the same answer, which is they have set up a separate, independent, single tasked water management agency. And it has all the power and all the authority to do one job, manage that resource. So all around New York State and all around the United States, states have come together where they're sharing a common resource, and they have set up these water management agencies that do the job of managing a shared resource. So we have the Delaware River Basin Commission that protects the water of New York City. We have the Susquehanna River Basin Commission on the right that manages the Susquehanna River that drains into the Chesapeake Bay. We have on the western edge of New York the Great Lakes St. Water Compact Management Agency. It's 8 states, 2 provinces of Canada, the Canadian government, and the United States government. We have other agencies, the New England Water Pollution Control System that looks at surface waters from New York to New England. We have the Interstate Environmental Commission that looks at New York, New Jersey, and Connecticut water issues. What do we need done here on Long Island? What would an agency do for us? Well, we need a lot more aquifer studies, and so it would promote those. It would promote sustainability. It would develop a science-based water allocation system. It would give us more information about our aquifers and develop a water budget. Right now, we don't even know how much water we can safely take out of the aquifer system based on science. So we need to bulk up our science. We need to do better data management. We need to deal with this problem of remediation for all these contaminated sites. And we need much, much more public education. So if we develop a Long Island regional compact that had the job of protecting our aquifer, it would be 24/7. It would be professional people here all the time taking care of groundwater. It would have the authority and the duty to not just plan for protecting the groundwater, but actually carry out those plans and implement them and have regulatory oversight. It would make regular reports to the public. It would take the big view of what's going on with the groundwater system, but also be sensitive to local concerns. It would understand that groundwater is a limited resource. It is not here forever, and it won't last forever the way we're using it right now. And groundwater is more than simply our drinking water. It's part of our whole ecological system. And so we need to manage it both as a part of the ecology and as our drinking water source. And if we followed the compact model, we would have long-term funding for the agency. And what would that funding look like? Well, if we spread it out across all of the people on Long Island, it would represent a fee for using the water that would be around $3.50 per year per person. That is the same level of cost that people were very willing to shoulder when we were talking about bonding programs to buy land. Why did we buy land? To protect the water. So it's a very reasonable price. So I'm going to stop here, and I'd be happy to take any questions you have.
We're going to pass the microphone around to people who have questions. Okay, so right here first, and I'm sorry, in the back first, and then I'll come to you in the front.
Any water recycled over time, so what percentage?
So the question is any water recycled? And are you meaning that we take used water and treat it and then use it again?
Yes.
We don't do that for any drinking water. There are some programs now where we collect water from sewage treatment plants, water from landfill treatment programs, some runoff from landfills, and we use that for irrigation and things of that sort. But we are not reusing any groundwater for drinking water presently on Long Island.
What percentage?
Very small, very, very small percentage do we do that around Long Island. Yes, sir.
Hi, thank you very much for coming and educating us on this subject. Since our groundwater is dependent on precipitation, it seems to me that if there's any real change in the precipitation, we are in deep trouble. Who manages that? I mean, I'm sure the weather forecasters keep track of that and,
Right.
For the year. Is that primarily who does it?
Well, the USGS tracks rainfall, So your question is, who tracks rainfall and who manages that, if anyone? And the answer is no one manages rainfall. The U.S. Geological Survey tracks rainfall. Some of the state agencies like the DEC does as well. We have no program for excessive rainfall. We do have kind of informal programs for drought, but we have no real drought action plans. So the state DEC, on advice of the USGS, would declare a drought watch or a drought warning or a drought emergency to let people know that rainfall is below normal, and that for us on Long Island, we should be paying attention to how we use water. But there are no formal plans, town by town or county by county, to do something about that. Usually the water utilities might declare a drought watch and ask people to not use so much water. But that's on a water district by water district basis. There's no overall planning for that in general.
Thank you.
Yes?
What is a water recharge area and who makes that designation?
Okay, so the question is, what is a water recharge area? Every inch of Long Island recharges water. But some parts of Long Island recharge water that goes deep, deep into the aquifer, and other parts, the recharge just stays shallow. The deep recharge areas that I showed on the map were designated by a study back in 1978. And it looked at how deeply into the aquifer system water goes. And the recharge areas were defined as only those areas where at least most of the water ends up going into the deeper reaches of the aquifer. So that is the area around the groundwater divide. That is the prime recharge area for Long Island. And it was devised in order to guide land use, because it was understood that the water that stays in the aquifer the longest period of time needs to be the cleanest, because it's going to be down there the longest, and it's going to be what we rely on long term. And the idea was to not put highly polluting activities in the middle of the aquifer where they can do the most damage. And so what did we do? We developed Long Island as if the middle of the island was worthless. And we value the property along the coastline as the most valuable. And so ironically, we developed Long Island backwards from a groundwater management standpoint. And we're living with the consequences today. So you read in the newspaper about the terrible contamination plume at Grumman in Bethpage. That site is very close to the groundwater divide. And so the pollution has reached down 800 feet. It is the most seriously polluted groundwater area in the state of New York. And we just got it wrong. Here's a question in the back.
Is desalination a viable option for Long Island?
So the question is desalination a viable option for Long Island? The technology for desalination is improving. It's still very expensive. So it is the most expensive thing you can do to provide clean water. There are many, many other things that we can do before we have to go to that. But if money is no option, it's there. Yes, ma'am.
This is a two-part question. Have you been consulted or done any consulting work to help fashion these regional management plans? And if so, what kind of resistance do you find institutionally or within the community that's trying to adopt it?
The question is, have I worked with those who are working on the regional groundwater management plan? I'm not exactly sure which one you're referring to, so maybe you could clarify that.
Anyone. I don't know of any of them. So
Okay.
we don't have one, so I'm thinking
All right, well, there's been many regional groundwater plans over the years. I have been involved in many of those. Right now, there are at least 3 major groundwater studies that are ongoing. One is very important out here to the east end, where the USGS is defining sub-regional watersheds that are looking at this question of water flow, how long water takes to reach the shoreline, so they can better define the areas very close to the coastline that need the most attention to prevent coastal water pollution. I'm not directly involved in that. I don't know if you are, Sarah, but that's one of the regional plans that are being conducted right now. There's a second regional plan called being undertaken through a group called LINAP, Long Island Nitrogen Action Plan. They're doing a study of how to control nitrogen. I'm not directly involved in that, but I'm working with people who are. The third study is a USGS DEC sustainability study for groundwater. And it's looking at all of Long Island and looking at what is a long-term sustainability for our groundwater resource. This was driven by people in Western Nassau, and I was directly involved in that. It's a 5-year study. I'm on the advisory committee for that, and we're very concerned about issues of saltwater intrusion, contamination, and depletion of the aquifer. And we should have some early results from that in about 2 years.
With respect to the amount of groundwater and drought, since you know all the numbers about the usage and rainfall, how much of a supply does the water people keep on hand? Do they keep 6 months in the towers, 3 months, a year, and they keep it that long to prevent these problems?
Okay, so the question is, how much water do we have in backup systems in case there's a drought? And the answer to that question is we don't do it that way. The water that comes into a storage tank goes out very quickly. You don't want that water just sitting in the storage shower for very long. You want it to be constantly being refreshed. So the plan for drought is the aquifer. That's where all the storage is. And so that's where we would go to for a drought emergency. And so it's not a great plan in terms of storage. There's a lot of water down there, but we can do real damage if we over-demand water coming out of the aquifer.
So if, God forbid, there was a terrorist attack with some pollution or something that destroyed the access for the water system, there is no backup.
Okay, so the question is, what if there's a terrorist attack? The answer to that is we're actually much luckier than, say, New York City. If New York City were attacked and real damage was done to a central part of their distribution system, it would impact millions and millions of people. Out here, our water delivery system is very fragmented. So even though you may be familiar with the Suffolk Water Authority, there are about 12 other major water suppliers in Suffolk County. There are over 50 in Nassau County, and you have over 200 non-community suppliers here in Suffolk County as well. So if an area of Brookhaven were attacked, it wouldn't necessarily affect any other part of Suffolk County. It would only affect that one small area that was the subject of the attack. So from a sabotage standpoint or an attack standpoint, we're in very good shape.
What would the political process look like to put in place the regional management system that you described?
If the system that I've described were to be established, it would require state legislation to authorize the setting up of a regional management agency. It would have local representatives sitting on the board of directors. They would set the policy. they would hire a full-time professional staff to do all the technical work and carry out the plans that the compact developed. Yes?
Would you be able to tell us something about the cesspools, how the water is emptied and where it goes?
Let me take this question and then I'll come back to you. So the question was, again, could you just repeat that? I didn't quite understand it.
Just about the cesspools and
Where does the water go? Okay, so the question is, when you drain water into your wastewater into a cesspool or a septic system, where does it go? It goes back into the groundwater. And for a standard cesspool or a slightly more advanced septic system, the treatment level is minimal.
One more question.
I have the microphone. Based on that, the septic systems, there's some controversy in East Hampton because they just passed a law which would, if you have a poor septic system, you can put in a new one. And they're using CPF funds. But my question to you is based on the flow, because there's a controversy about how long it would take to get rid of the nitrogen in the groundwater. So I'm asking you if you have a good, some people say it'll take so long, it'll be 10 years, it'll be 20 years.
Okay, so the question is, regarding the new systems that are being promoted, how long will the pollution stay in the ground? And so the answer I gave you on the slide, it depends on where the septic system is. If it's very close to the shoreline, that wastewater that gets into the groundwater will discharge quickly in the matter of years. 1 year, 2 years, 5 years, something like that. If it begins as wastewater discharges more toward the center of the forks, or close to that groundwater divide, it can stay in the system for hundreds of years. But as it moves through the system, it will dilute. So it won't be so concentrated as it was when it started out. So I think most of the attention is looking to deal with the systems that are close to the shoreline and have a very rapid discharge time and concentrate to get that discharge as clean as possible. And I think that's the right strategy. I think we're going to wrap it up here.
Yeah.
Sarah,
Thank
thank
you,
you.
Thank you, everyone, for coming, and Sarah Malin will still be here if you want to corner her with a private question.
Yes, sir.